Welcome back here to Amplify 208. I've kind of decided to kind of do this video here. Maybe as like a little rant, I guess. This is my little rant video, I guess, about the hi-fi community and a lot of their nonsense when it comes to vintage hi-fi gear and just a lot of just ridiculousness like power cables and speaker cables and when they get into this skin effect bullshit. And yeah, there's probably going to be profanity in this, so if there's kids around, don't watch this video. Yeah, so when you're dealing with hi-fi equipment, it boils down to topology, okay? Not necessarily, you know, I want this amplifier, and let's say you have a Sansui, Pioneer, Kenwood. It doesn't matter what it is, Hitachi. It doesn't matter, okay? All the components in Sansui, uh, Iowa, like Techniques, Hitachi, JVC, Fisher. You could go on and on. There's obviously, the major ones, Marantz and Macintosh. One of my faves, Macintosh. Beautiful designs. The same with, like, a lot of the Marantz designs are beautiful. Especially when you get into the class G's and H's. They're a little different topology than your standard. This one here is your standard class AB topology. But, like, the back to my ranting issue is the fact that uh, power is do your homework, okay? You can put these big massive power cables on and everything else. It ain't gonna make a damn difference in the sound, okay? Not at audio frequency range. If you're dealing with gigahertz, yes. And the reason I make this rant video is I've been watching these videos in here, and I'm not gonna mention names on other channels, but when they sit there and they're saying, "Oh, you got to use this speaker cable because the sound stage is phenomenal, and it makes the instruments stand out and yada yada yada, and oh, it's so beautiful." And you know what? That's all hogwash and bullshit. Basically, it boils down to if anybody knows what I'm talking about back in the day, like frequency transition and megahertz of the speed of the transistors. Okay, your beta, your gains, the frequency transition of the frequency transition. Okay, that's your megahertz of the frequency transition of the transistors. That, believe it or not, that does kind of have some merit. Okay, and I'll tell you why. The reason that it has merit, and I'm sorry if the video is wobbly. I don't have fancy camera equipment yet, but I'm gonna work on it. And but this is all done handheld with a phone. But I just want to start, showing the community that this shit can be done with simple stuff, and you can revive these old pieces of vintage gear that are just for years to come, that are not made anymore, and you can fix if you use your head and do your research, okay? And use reputable people online, on YouTube, on those other platforms. For example, X-Ray Tony. Check out X-Ray Tony. The guy is a genius. Trevor's Bench. Check out that guy. He is a genius. Joe's Bench. Very good. X-Ray Tony, you'll learn a lot. Check out kissanalog.com with Eddie Aho. That guy is a military engineer. He works for the government, okay, in the United States. Building contracts, licenses, switch mode, power supplies. He fixes space stations and everything else. Like, those are these guys you want to watch. X-Ray Tony is a guy that owns his own X-ray company. These are the guys you want to learn from. Get your resources from reputable online dudes, okay? You will learn how to do stuff, and you will learn how to fix stuff, okay? Plain and simple. That's all there is to that rant. The other rant about audio cables and all the other stuff, you don't need it. It's all bullshit. I'll even put a link up or a little video pop up here and there. But most guys, if you know what I'm talking about, you know what I'm talking about, and it doesn't matter. And not unless you're dealing with, not in the audio frequencies anyway, from 20 to 22,000 kilohertz, if your ear can even hear that high. I think mine can hear about 18,000 and it starts to fall off, which is pretty good for my age. But yeah. But you see some of the videos with the guys with the power cables, you know, they're up off the floor and the things are like, you know, an inch thick and, you know, oh, it made the soundstage open up by just putting this power cable on. And, okay, I got news for you, bud. Guess what? You just stuck that power cable into the back of your receiver. Okay, yeah, great idea. Okay, yeah, you spent how much money on it? $1,000? Oh, okay. Do you realize the cable that you just installed? Yeah, be quiet over there, meter. The cable you just installed plugs into a standard 14.2 or 14.3 style copper wire, solid wire that goes inside your wall that hooks to your receptacle that goes to a panel. And that wire right there, I guarantee you're not spending $3,000 for or $1,000 for, but you plug it into a wall, okay? And if you're using a line frequency switcher, which is a standard regular linear power supply, it's not even really linear. This is not linear. It comes up to this point with a regulator, then it becomes linear. This point is unregulated. It's a low speed line frequency switcher. It runs at 60 hertz or at 50 hertz, depending on where you live in the world. And then after it goes through your bridge rectifiers, it gets stuffed into these big old bad boys right here, which is your power supply filters. Okay? And right here, after that, it don't matter what your line is doing on this side, going to your wall. This right here does not give a shit what the rest of the circuit's doing. This here, you know, I don't even think this one has EMI filters. I don't think it does. Well, it doesn't. But anyway, it doesn't matter. It's not a switch mode. It doesn't, you know, have high frequency pulsing on it or anything. This is a line frequency switcher, low speed frequency switcher. It switches it. You get your 60 hertz. You full bridge rectify, you get your 120 hertz, whatever. It's going to be filtered out by these. It's going to be nice, clean DC. You're not going to worry about it. It's not going to happen. You're not going to be introducing RF into your power wires. It's ridiculous, okay? Plain and simple. Oh, there's my dog having a drink. She's such a good girl. Great Pyrenees. She's a big puppy. She's a big puppy. Hello, puppy. Okay, anyway, back to the rant. But anyway, yeah, I've had this here is the one I made a video on earlier. It's kind of a little bit of my rant. This is the JVC R-S7 stereo receiver. I've been sitting here for a while, and I did mention I'd bring up a video on the bias. As you can see, the bias is only sitting at 4 millivolts. But I've been running this thing for a while. It jumps up. It's supposed to be at 5 millivolts. Sitting at 4, 4.4, 4.2. It was jumping around. It's kind of cold in here. So, yeah, I don't know about that. Sorry about that. My camera crapped it. So, yeah, we're sitting like at 4.2, 4.3 millivolts. So what we're going to do here, I'm going to grab a screwdriver here, and I'm going to adjust this bias pot down here. As you can see, I am across the test points. I'm gonna up this a little bit here again to 5. Let's see which one. I think this is right. Yeah. Ooh. And you can tell these are 1-turn pot, so they're very, very touchy. I prefer my 10 turns. And then, like I said, I've been tweaking this thing for probably good. Playing a little bit of music, turning it up, letting it cool down, see where it settles. Right now I have the speaker terminals, the speaker in the position off, because if it has a DC offset, I don't want, whoops, I don't want 5.2, I'll leave it to 5.2, and then we'll adjust this other pot for the left channel. And you basically breathe on these one-turn pots, and it jumps big time. 4.9. Come on, bump, bump. There we go. 5.2, 5.3, 5.3, 5.3. Perfect. Okay, I'm happy with that. Okay, yeah. So when I first powered this up in the last video like this, I said I was going to check the bias and everything like that. And I'm glad I did, because the second I powered this up, within probably about a minute, this thing jumped up to about 12 and a half, 15 millivolts, and I kept climbing on DC idle current, and it was only supposed to be set to 5, which was actually impressive, because the heatsink actually stayed cool. But the specifications say 5, but it runs way too cool at 5. But you know, but there's still no crossover distortion that I can see. I'm gonna put it in, like, I might put some waveforms on it, like signal generator through it, and put a waveform, but I definitely cannot hear it. You can hear it if it's distorting. If you work on audio gear long enough, you know something's distorting. It has distortion or not, because you know, you should. Because if you don't, you should go back and do your homework. Anyway, like when it comes back to audiophiles and speaker cables and all this other stuff, speaker cables, it's basically, guys, do your math, okay? If you're putting out 100 watts, make sure your power cables from your speaker amplifier to your speakers cable can handle the current that it needs to handle. That's it. Don't worry about frequency response or anything like that. Don't worry about it. Yes, it can play a factor. It doesn't play a factor if the cable is heavy enough to handle the current. It's that simple. If they needed huge and massive power wires and huge speaker cables and needed to stick them up and make them full of silver and titanium and whatever you would like to think of the magical ingredient would be, you think they'd use it on the space shuttle or the International Space Station. But guess what? They don't. It's OFC, oxygen-free copper. It's your standard gauge. They do the math. They say, hey, this wire's got to carry this current. And then that's what they use. It's not rocket science. It's hi-fi. It's a difference. It's audio frequency. It's not gigahertz. It's not megahertz. It's, you know, there is kilohertz. Yes. Well, it is megahertz if you're going to the tuner section, but that's a different story. But but the audio frequencies are not in the megahertz. It's 20 to 20,000 kilohertz. There's no skin effect in speaker wires. Don't let them tell you that there's these transients and the dynamics and the depth of it. Not deaths. The depth of it. That's to do a lot with your speakers and the content you're listening to, whether it's any good or not. Whether it's got good quality sound. If it doesn't, well, then it sucks. But yeah, but other than that, that's kind of a quick rant on my behalf. So anyway, yeah. End of rant. I'm done talking about it. I've watched so many videos and I've seen so many just speaker cables, audio interconnects, and all this other stuff that you spend thousands of dollars. Don't waste your freaking money, folks. It's not worth it. Use a regular set of RCAs. Don't run your RCAs. Do good cable management, and you will never have a problem. It's that simple. Unless you're doing huge long runs. That's the only time balanced connections or unbalanced connections suck, is when you're doing long runs and it's low voltage and it can pick up all the extra interference from switch mode power supplies and all the RF being generated. That's when it could be an issue. But a good amplifier topology, doesn't matter what you put in it for capacitors, as long as you match the transistors. If the circuit design is good, the topology of the amplifier is good, it doesn't matter the components, as long as they're within a certain spec. If they meet the factory specs of the original components, it will be better than what originally was designed from at the time. When they had these stereo wires back in the days, these guys put in the best of the best they had at the time to make the units work. Why not do that now to the same stuff using that topology circuit design put the same components in, and you will get those kind of returns in, but yet with lower distortion, because capacitors now and transistors now, maybe not as fast, but the capacitors are definitely better in quality. And you will get lower distortion, you will get good numbers, and you will not tell the difference, especially when it comes to all the Class D stuff. Class D stuff, it's a whole different animal. Not a fan of the sound of Class D. I just don't find it being the same punch. It doesn't have the same kick in your chest. Maybe the real high-end stuff with a lot of power. I've heard some good sounding Class Ds, but it does not beat vintage hi-fi Class A, B, G, H. It does not beat it. Or even bridge tie load, depending on what it is. Even sticking a Class A, B design like a vintage stuff with even a switch mode on it with some good filtering on it. That doesn't sound too bad either, but it still lacks that punch in my opinion. But that's my opinion, right? A lot of it's subjective. That's what I mean. Do your research. Do the science. Crunch your numbers. Don't listen to the audio fools. Don't spend $1,000 on speaker cables. Just buy good oxygen-free cables. Know that, hey, this my speaker puts out, or I said my amp puts out 200-300 watts. Well, then have a cable that can run and carry 200-300 watts without even breaking a sweat. That's what you do. You'll never have a problem. End of story. I hope that little part of the rant kind of, help people out not to waste your money. Like, don't waste your money. Do A/B blind tests. You will find out. Okay? So that's just basically the end of the story on that one. Anyway, back to this one. This isn't part 3. This is just my rant about kind of anything. This thing runs good. We're going to put some lights in it soon. I have been tweaking the bias here. I got it set up at the bias points. Meter shuts off all the time. I think they're running at 5, 5, 5, 6. Supposed to be running at 5, but then as soon as I start playing it, or switch into the speakers, it'll go up a little bit too, because then I'll put the speakers current across the speaker load. So then I'll switch out the speakers, and then it drops back down. And then if I sit here and breathe on it, it changes. But like I said, I've been waiting for this thing to warm up. And even at 5 mils, like 5 millivolts across these emitter resistors, the thing hardly even gets warm. Like, it's basically room temperature. The temperature in this room right now is 22 degrees, and like, this thing's not even warm. Transformer's not even warm. A little bit warm. Voltage regulator, yeah, it's definitely warm. I don't know why they put such a small heatsink on that, but that should have been bigger. All the power supply caps, be careful, put your hands in here, because there is voltage in here. Feel the top of the transistors. Like all these things are, they're all cool. All running nice cool. Even the caps, if the cap has high ESR or leakage, stuff like that, you'll feel the temperature change right in the capacitor itself, and you'll also see it and you can tell once I back the bias down. It doesn't have the LED, like the panel lamps on, but it's only running 19.2 to like 19.3 watts, right? The line voltage is a little low right now, but 119, 120, that's average around here. But everything's still working good. The tuner works amazing. Like, I've been pulling in and listening to radio all night long. Of course, indulging in the old Canadian brew, but of course. But this is what this hobby's all about. This is my hobby. Thank you. This is my hobby, and I absolutely love this vintage gear. I think I wish a lot of people would get into this. It's a dying art for sure. And I just hope there's a lot of people out there that would like to kind of hear what I have to say. I don't know. I'm not much into bullshit. I tell you how it is, and that's all there is to it. If it's good, it's good. If it's bad, it's bad. That's all there is to it. And for that, I thank you for watching, and have a good night. And I wish everybody a great evening.